Hi students. Yeah, today we are going to discuss about order of stability of different types of carbocations. You know, tertiary carbocation, secondary propyl carbocation, ethyl carbocation, methyl carbocation, which is more stable. Yes. Then allyl carbocation, benzyl carbocation, which is more stable. Phenyl carbocation, benzyl carbocation, which is more stable. Allyl carbocation, isopropyl carbocation, which is more stable. Next, allyl carbocation, N-propyl carbocation, which is more stable. Then triphenyl carbocation, diphenyl carbocation, benzyl carbocation, which is more stable. Then benzyl carbocation, tertiary butyl carbocation, which is more stable. Then benzyl carbocation, allyl carbocation, secondary butyl carbocation, which is more stable, right? Then triphenyl carbocation and phenyl carbocation, which is more stable. Some specially stable carbocations are there, that is tropolinium carbocation, cyclopropyl carbocation, cyclopropyl methyl carbocation, that is CPM carbocation, right? These are all we are discussing in this video with very easy, simple tricks. By using the tricks, by seeing the question, you have to answer it. Yeah. Now let us follow. Let's start now. First one is a tertiary butyl carbocation. Isopropyl carbocation, ethyl carbocation, methyl carbocation, right? The stability of these carbocations we can explain by applying two electron migration effects. One is hyperconjugation effect, other one is negative effect. First, you can apply hyperconjugation effect. Carbocation adjacent carbon is alpha, alpha, alpha. In hyperconjugation, alpha hydrogen, there is 8 sigma bond sigma electrons are in conjugation with the positively charged carbon containing vacant paired bonds, right? Yeah. So that means hyperconjugation is mainly depends on number of alpha hydrogen atoms which are participating in the hyperconjugation effect, right? Yeah. Now here this carbocation having 3 alpha carbons are there, and this carbon have 3 hydrogens, here 3 and here 3 are there. That is total number of alpha hydrogen atoms how many? That is 9. And this carbocation, this is alpha, alpha and 2 alpha hydrogens are there, each one having 3 alpha hydrogen atoms, totally 6 alpha hydrogens are available here. And this is ethyl carbocation. In this it is adjacent carbon alpha, it have 3 alpha hydrogens are there, right? Yeah. In this methyl carbocation, there is no alpha carbon, so that's why there is no alpha hydrogen, 0. There is no alpha hydrogen, there is no hyperconjugation effect, yes. Yeah. Now, so now as number of alpha hydrogens increases, stability of carbocation also increases, right? Next, second effect, there is a number of alkyl groups that is responsible for positive and negative effect groups. How many are there here? So this is a that is methyl group, CH3 group is there, methyl group, right? So how many are there here, my dear students? Here it is 1, 2, 3. You know, this methyl group is the electron releasing group. It releases electrons. It is a electron releasing group. It releases electron to the carbocation, right? You know, carbocation means it have only 3 covalent bonds, 6 electrons are there. It needs 2 more electrons to get stability, so that's why it is unstable, it is crying. Okay, so then immediately this alkyl group is there. It is a electron releasing group, it is a good friend. It is releasing electrons. Electrons are negatively charged that can nullify or neutralize the positive charge obtained over the carbocation, right? Then it is going to be stabilized, right? That means you are crying, you are unhappy because you want to eat some chocolate. The chocolate cost is some rupees, but you don't have that much of money. Then you ask your friend, he is giving, then you go and buy the chocolate and you are eating, then you are feel happy, that means you are stabilized. That means when you are crying, you are unstable, then your friend is giving help, then you are getting stable. Like that here also, it is a electron releasing groups are good friends. Then they release this electron to the carbocation. Whenever carbocation is crying, then this alkyl group says, don't cry, I am here, I am giving electrons to you, like that. So they are giving electrons. Such groups are there, 3 are there. This is a methyl group, this is a methyl group. So 3 electron releasing groups are there. Then they readily release this electron. Then the tertiary carbocation is going to be stabilized readily. Yeah. So that's why there is a number of plus I groups is 3. Right? Yeah. This one, it is a isopropyl carbocation or secondary propyl carbocation. So in this one, this is a methyl group. It is releasing electrons. It is also releasing methyl group. 2 alkyl groups are there. There is a number of alkyl groups are 2 are there. This is also releasing electron to the carbocation. It is also going to stabilize. But compared to this one, tertiary butyl carbocation and this isopropyl carbocation, number of plus I groups, electron releasing groups are 2 only. So that's why it is less stable than tertiary. Yeah. Now come here, ethyl carbocation. Here we have one methyl group is there. It is releasing electron to the carbocation. It is going to be stable, right? But number of plus I groups are only 1. So that's why it is less stable than secondary propyl. Then here there is no electron releasing groups. It is crying only because there is no good friends to give electrons to stabilize. So that's why it is highly unstable, right? Then you can get conclusion, my dear students. As if you move from methyl group towards the tertiary butyl group, if you move it, then number of alpha hydrogens increases from here to here. Yeah, from methyl to tertiary butyl group. At the same time, the same manner, number of plus I groups, positive and negative groups or electron releasing groups also increases. Then stability of carbocations also increases, right? Stability of carbocations also increases. Then you will get a conclusion. Just I'll give one small trick. You just keep that trick in your mind. Kim means keep in your mind. The trick is, what is that is here? The stability of carbocation is directly proportional to number of alpha hydrogen atoms, or is directly proportional to number of plus I groups, that is electron releasing groups. Is it clear? Okay. Just keep this trick in your mind. It is very easy to answer this type of questions. Yeah, is it clear? Fine. Next we go for another question. Take it here. It is a alkyl carbocation. Here 2 hydrogens are there, 2 bonds, CH2. Here 3 bonds, 1 hydrogen, and here 2 hydrogens, CH3, CH2, double bond, CH, single bond, CH2 plus. It is a alkyl carbocation, right? Yeah. Then next one. Here OH group is there, and it have lone pair of electrons are there in oxygen atom. This carbon carrying positive charge, right? Yeah. Now, so of these two, here 3 hydrogens are there, and 1 hydrogen, and this is OH group, right? So of these two, which is it is a JEE mains and advanced question. It is very important question, right? Yeah. So how to answer this? So of these two, which is highly stable, my dear students? Yeah. Which effect is explained to the stable this one? So in this compound here, this carbon carrying positive charge, and this is a pi bond, and there is a sigma bond positive charge. You know, pi bond, sigma bond, positive charge is there. Then that is called what? Conjugation. The entire organic chemistry, wherever conjugation is there resonance is take place, my dear students. Resonance is take place, resonance effect. Okay. So because of that, what happened? These pi electrons are there, right? These pi electrons are shifted toward this, the delocalized, and it is going to be stabilized here, right? Okay. Then what you will get? You will get the structure like this. There is you will get, there is a C, okay, and here a double bond, and here this carbon gets positive now. It is going to be stable now, right? Okay. Now that means this carbocation, alkyl carbocation, is stabilized by resonance SBR. What is that SBR? Stabilized by resonance, stabilized by resonance, stabilized by resonance. Okay, that is S Bhaskar Rao or S Bhaskar Reddy, like that you have to keep in our mind. It is very easy to relate the concept. Yeah, SBR is there, it is going to stable, that is resonance effect is there, right? So okay, then come here. In this case here, so this is a OH group is there, oxygen having lone pairs of electrons are present, okay, and this is carbon, adjacent carbon, alpha carbon is there. Here 3 alpha hydrogens are available, fine, okay, and here, so hyperconjugation is take place here, hyperconjugation. So hyperconjugation is take place here, hyperconjugation, fine, okay, fine. Then another thing is, so because of this, the 3 alpha hydrogens are they form 3 hyperconjugate structures. Will get hyperconjugate structures. How many will get? 3. Okay, fine. Then here this is lone pairs of electrons are present. Lone pairs of electrons. Okay. Then this lone pairs of electrons, and this is sigma bond. This is positive charge. Okay. You know, wherever lone pairs of electrons and sigma bond and positive charge is there, right? Lone pairs of electrons, sigma bond and positive charge is present. So that's why here what is there? Conjugation is there. Wherever conjugation is there, then what happens here? Resonance effect is take place. And that too here, one more thing my dear students, here, this is a OH group, right? Yeah, you know, OH group, okay. So this is a, according to, wherever conjugation is there right here. So that's why here it is act as a plus M effect group. It is a plus I group, okay. So mesomeric effect is take place, plus M group is there. So it is by this lone pair of electrons, it is delocalized, make a double bond here, carbon oxygen double bond will get. Then after that, what you will get now? So here carbon and a double bond and oxygen, and it get only one lone pair is there, it gets positive charge, right? Yeah. Then this carbon having how many electrons now? This carbon having here one hydrogen atom is there, right? This hydrogen atom, okay. So 1, 2, okay, 3, 4, 5, 6, 7, 8. So this carbon have 8 electrons it have. So this have 8 electrons, okay. Then oxygen, what about oxygen? 1, 2, 3, 4, 5, 6, 7, 8. Oxygen also having 8 electrons. So here both carbon and oxygen, okay, having octet configuration, octet group. So that's why both elements are stable after delocalization of lone pair of electrons to the carbon and make a bond with that, right? Okay, fine. So here hyperconjugation effect is take place and the mesomeric effect is also take place. So that's why, okay, it is more stable than allyl carbocation. Got it? So keep in our mind one simple trick, my dear students. Here the trick what you have to do it is, the trick is, for this case, it is very important trick, a special trick, that is here. If in a given compound, the carbocation adjacent atom is alpha, right? Okay, it is the alpha atom. Okay, it is the alpha atom. Alpha, okay. If the carbocation carrying alpha atom, okay, having lone pair of electrons, having alpha atom having, okay, 1 or greater than 1 lone pairs of electrons are present, then their mesomeric effect is take place, then that give more stability, okay. That's why then what happened here, there is a plus M effect is there, so then the delocalization of electrons that give more stability, okay. There is a simple trick, you have to follow it, you keep in your mind, my students, keep fine, okay. Yeah, up to here you got it, my students, inside, right? Is it clear? Yeah. Then next one is the means here the atom, the carbocation adjacent atom, that is alpha atom, it may be oxygen or nitrogen or halogen. If it having lone pairs of electrons, then that lone pairs of electrons are used for stabilization purpose, and that atom and carbon atom both are get 8 electrons. So both atoms are having octet 8 electrons. So that's why that is gives more stability to the carbocation, right? Yeah. Next, another example. Like here, a phenyl cation and then a benzyl carbocation. Right, benzyl carbocation. Now, phenyl carbocation, benzyl carbocation, which is more stable. Here, in the case of benzyl carbocation, this is a pi bond, it is a sigma bond and positive charge. So here pi bond, sigma bond and positive charge is present. Okay, that means what? Conjugation is present, my dear student. So wherever conjugation is present, my dear student, there resonance is take place. Resonance effect is take place. So then the compound is stabilized through resonance effect. That means the compound is stabilized by resonance. Okay, it is SBR means not Seral Basveswara. That is stabilized by resonance. I gave here stabilized by resonance. Fine, yeah. And in this case, phenyl carbocation, it is not stabilized here because here there is no conjugation. Okay, got it. That's why phenyl carbocation, it is stability is very less. That's why benzyl carbocation is more stable. Got it. Next one. Yeah. So this is a alkyl carbocation and this is CH3, CH3, right? This is middle carbon is positive. It is a isopropyl carbocation of these two, which is more stable. So in this case, as you know, here we did, that is what happened here, pi bond is there and these pi electrons are migrated delocalized over here. That means here a conjugation is present. Wherever conjugation is present, there resonance is take place. So that's why it is stabilized by resonance, SBR. But in this case, which effect is operated? Here no conjugation. No conjugation means next you have to check it which electron migration effect is going to operate is, that is maybe inductive effect or hyperconjugation. It is a alpha carbon, it is a alpha carbon. So here 3 plus 3, 6 alpha hydrogens are available. So that's why it can form 6 hyperconjugated structures. Okay, yeah. Okay, so this is the carbon hydrogen bond is there. This CH sigma bonded electrons are in conjugation to the this here vacant pure p orbitals. Then it is going to stable. That is called hyperconjugation. Like that, we will get 6 hyperconjugated structures. Will get, yeah. So this one, this one, this one. Okay. So it forms one structure. It forms 3, and here also the same thing will get it here. So here also these 3 alpha hydrogens they may involve, and you will get it. That is, it may be one hyperconjugate structure. It forms one hyper. This one like that. Totally 6 hyperconjugate structures will get. Yeah. This is called what? Hyperconjugative structures. Hyperconjugative structures. Okay. Hyperconjugative structures. HCS, right? So it is stable. Then that too, one more thing, my dear students, here. So in this case, it is a, it is a plus I group. There is alkyl group. It is also plus I group. Like that, the number of plus I groups, how many are there here? 2 are there. So that means this is stabilized through inductive effect also. Okay. So here hyperconjugation effect is operated and also inductive effect is operated. But so the predominant effect is which one? The predominant effect is if the molecules in the given pair, the one molecule is exhibiting a resonance effect and another molecule is exhibiting hyperconjugation and inductive effect, the predominant effect is resonance effect. This point you have to keep in your mind, my dear students. Yeah, okay. That is, if the molecule, that is about the predominant effect. Predominant effect we have to apply is here. That is, the resonance effect is predominant than hyperconjugation effect, which is predominant than inductive effect. Okay, This point you have to keep in our mind, my dear students. This is key, you have to keep in our mind. Okay. So that's why allyl carbocation. This is what? This is a allyl carbocation. This is allyl carbocation. Allyl carbocation. It is more stable than this is what secondary or isopropyl carbocation. Isopropyl carbocation is less stable than allyl. That means allyl is more greater stability, right? Yeah. Next one. Next one is another example. Look at here. The molecule is like this. Yeah. So here this molecule, here it is a positive charge and pi electrons is there, and here positive charge, pi electron is there, here positive charge, and here one alkyl group is also there, right? So which is more stable here? So according to check here, this is this carbon carrying positive charge. This side what is there? Methyl group is there. It is a methyl group. It is a releasing group. So it is plus side group, right? Okay. So that's why it releases electrons. Okay, fine. Then here what is there? This pi bond is there, and sigma bond is there, and positive charge is there. You know, wherever pi bond, sigma bond, positive charge is there, then what happens? There is conjugation is take place. Conjugation is take place. So once conjugation is take place, means that is conjugation is there, means it is stabilized by resonance. Okay, yeah. And also inductive effect is also operated. That means here resonance effect is happening. It is stabilized by resonance, this carbocation, and also it is stabilized by inductive effect, and also stabilized by inductive effect. Okay, okay, fine. So this carbocation is stabilized by both resonance effect and through resonance effect and also inductive effect. Yes. Come here. In this case, so here there is no alkyl, that is okay, and that too here this it is also releasing, it releases, okay, and here this is same thing, that is pi bond and sigma bond positive charge, that is so these electrons they may migrate over here, then it stabilizes here also, that is happening, and it is going to stable, right? Yeah, okay, it is going to be stable, right? Okay, yeah. So that means it is stabilized by resonance, okay, and this is, but here like this it is the methyl groups are not there to stabilize, okay. Then come here. In this case, what is there here? There is no resonance, okay. So this stabilized by through this groups, this methyl and this methyl, that is inductive effect. Here only inductive effect is operated. Here in this case only inductive effect, only inductive effect, only inductive effect stabilize the carbocation, and here resonance effect SBR means what, my dear students? So here resonance effect is take place, resonance effect is take place, resonance, okay, and then inductive effect is take place, okay. But here these groups are there, this side and this side, so two side groups are there, but here only one side, it is this side also, this side also. That's why this is extended inductive effect is take place, so that's why it is more stable. Next it is and then this is least inductive, only inductive effect. Got it? Is it clear? This is the way how to do answers. Fine one. Next one. Next, another example. A molecule having yeah. So in these molecules, which is more stable, which carbocation, right? So here we have to apply. So in this case, this carbocation, it is this side with methyl group is there, and this side and this side. So that's why it is a tertiary carbocation, my dear students. Okay. So being a tertiary carbocation, okay, it is a tertiary carbocation. So it is all the three sides it is getting electrons. It is going to be stabilized readily, most greatest stability. But in this case, this is stabilized with this side with one, this side with one. Okay, that's why it is a secondary carbocation. Okay, and this one it is a primary. It is stabilized by this one. So okay, so that's why here. So as you know, the tertiary carbocation is greatest stable. In the first example we did, then the secondary, which is more stable than primary. Is it clear? Right? Yeah. Next one. That means here you have to apply which effect? That is negative effect. Negative effect. But in this case here, what is there? Alkyl group is there. There is CH3. So they may hyperconjugate. That is how many alpha hydrogens are there? 3 alpha hydrogens. So they can they can form 3 hyperconjugated structures. So that's why here both negative effect and here also is there here. This is also how many alpha? This is alpha. This is alpha. Okay, got my dear student. So sometimes they frame the questions. The given molecule stability is explained by which among the following electron migration effects. Yeah. So to do answer that, you have to know the just check it. Maybe first you have to check it. Maybe any lone pair, pi bond, sigma bond, positive charges are there. Okay, like that. Maybe conjugation is there or not. If conjugation is the resonance effect or mesomeric, then but here conjugation is not there, you have to go for next alpha hydrogens are there, hyperconjugation, then methyl groups, alkyl groups are there, then inactive effect, like that. It is very easy, right? Like that you have to read, follow, yeah. Then come here. So in this one hyperconjugation, yeah, we'll get 3 hyperconjugated structures, yeah. Then also and here this is also alpha, this is also alpha. Here how many are there? Here how many are there? This is here 2 alpha hydrogens are available. Here also 2 alpha hydrogens are available. Here 3 are available. Totally, how many alpha hydrogens are available is here? Totally, there is 2 plus 2, 4 plus 3, 7 alpha hydrogens. You will get 7 hyperconjugated structures. And that too, this is methyl group. It is responsible for plus side group. Okay, so that's why your hyperconjugation is effective take place, and also negative effect is also take place. It is stabilized by both these effects. Both effects. Both hyperconjugation and negative effects stabilizes this molecule, right? And what about here? So in this case, so this is alpha and this is alpha. So in the alpha, how many alpha hydrogens are available? So here this is 1, 2 are there, and here how many are available? This is alpha. Here how many are there? Only 1 is there. Only 1 alpha hydrogen is available. Totally 3. How many alpha hydrogens are available, my dear student here? So in this case, only that is 1, 2 plus 1, 3 alpha hydrogens are available. So that's why it can form 3 hyperconjugated structures. So that's why it is and then inductive effect that is happening, but it is somewhat distance. Inductive effect is depends on distance, right? So it is directly attached to there is tertiary carbocation methyl group, but its distance is more. Okay, so that's why inductive effect is also operated, but distance is less. Sorry, distance is more in this case. As distance is more, but here it is okay, directly bonded to the tertiary carbocation, that is alkyl group, right? Directly releases, right? So effect is more. Okay, yeah. So then come here. In this case, this is alpha. Okay, and here how many alpha hydrogens are there? 1. So only 1 alpha hydrogen is available. So that's why it can forms only 1 hyperconjugated structures. Okay, and inductive effect is there, but it is distance is more. So inductive effect is negligible here. So that's why you can get the order is, so first one, next second one, next third one is less stable. First one is higher stable, greater stability, right? Is it okay? Fine, got it, ma? You're following my students? Yeah. Next one. Next one is another example. Yeah. So here CH2, CH2 positive charge, CH2, CH3, CH2 positive charge, right? So this is what, it is also previous year question, my dear students. Ma, it is allyl carbocation, okay ma. Yeah. So this is what primary, this bond, this carbocation is one more carbon. It is a primary. It is a primary carbocation, or that is it is primary propyl or N propyl carbocation. Okay. Yeah, N-propyl carbocation. This is allyl carbocation. Of these two, which is more stable? Yeah. So which effects operated to get the stability, to understand the stability? Which effects are operated? Yeah, we'll discuss now. Come here. So this is pi bond sigma bond positive charge. Wherever pi sigma positive charge is there, their conjugation is happening. Okay, my dear ma, conjugation is happening, ma. So what you have to keep in mind? Where conjugation is there, their resonance effect is take place. Their resonance effect is take place, right? That is, this is stabilized by resonance. This is stabilized by resonance. Okay, resonance stimulation is happening, right? SBR will mod. What is SBR? Yeah, that is resonance. It is stabilized by resonance. Resonance stability gives more stable carbocation. Then what about here? This is carbocation and this is alpha carbon and this is two alpha hydrogens are available. These alpha hydrogen sigma electrons are in conjugation with the positive charge empty atomic orbital. Then this hyperconjugation effect is take place. How many? Two alpha hydrogens are available. We get two hyperconjugated structures. You know the number of hyperconjugated structures formed by the given molecule is directly proportional to number of alpha hydrogens that are available. Okay, so here two alpha hydrogens are there, that forms two hyperconjugated structures. Then okay, fine, and this group is a ethyl group, right? Okay, so this entire group is behave as a electron releasing group, that is plus I group. Okay, so plus I group is also there, inductive effect is also happening, right? But of these two, which is highly stable means, you know, the predominant factor I gave, right? What more? The predominant factor is, or the predominant effect. We can say predominant electron migration effect. Which effect is predominant is here? Resonance and hyperconjugation and negative is there. You just now know resonance effect is gives more stability to the carbocation than hyperconjugation, which is give more stability than negative effect. Okay, this you have to keep in our mind, my dear students. So that's why, but keep okay. Then we applying this, which tell me now allyl carbocation is more stable than N-propyl because here only two alpha hydrogens are available, right? Yeah, got it. Next one, another example. Next round. This is a triphenyl carbocation. Triphenyl carbocation. Next one. Yeah, this is a biphenyl carbocation. This benzyl carbocation. Yeah. So this is very important. Triphenyl carbocation. This biphenyl carbocation. And this is benzyl carbocation. This is all time favorite order, that is question, my dear students. Yeah. See, it is how to, which effect is operated here. Yeah. First of all, you have to check it. Here, carbon carrying positive charge, maybe alpha carbons are available, alpha hydrogens are available, then any plus I groups is available. Okay, and then any resonance conjugation is available. You have to check it. So here, so this is a pi bond and this is sigma bond, this is a positive charge. So wherever pi bond, sigma bond, positive charge is there, which one is happening? There is conjugation, that is, wherever conjugation is there, my dear student, there resonance effect is take place. Resonance effect is take place, right? Okay, fine. Now here, this one, resonance effect means, here what I meant, these pi electrons are the right, they migrated over here. Okay, it is getting stable. Then these pi electrons shifted over here, they delocalize, right? Like this, the pi bonded electrons are delocalized along the length of the carbon chain, that is going to stabilize by this carbocation, right? Like that, how many structures you get? 1, 2, 3. You get 3 resonance structures you get here. Then same thing here also. These pi electrons are shifted over here. They delocalize and get stable. Then it is migrated over here. It is migrated. Then you get 3 resonance structures here also. Then here also these pi bonded electrons are migrated over here. Then this migrated over here. So like along the length of the carbon chain, these pi electrons are migrated along the length of the carbon chain, that gives stability to the carbocation. Here also you get 3. Totally, so how many resonance structures you get? How many resonance structures you get? That you have to consider it here. You know, the stability of carbocation is depends on number of resonance structures. So this compound can form the number of resonance structures. Number of resonance structures is how many here? There is 3 plus 3 plus 3. 3 plus 3 plus 3 plus 1 in the beginning one. So totally how many? You get 10. So 10 resonance structures you get from this one. Right? Got it? You get how many totally? There is you will get here 3 plus 3 plus 3 plus 1, totally 10 you will get. Yeah. Come here. In this case, here these pi electrons are there. So it is migrated over here. And they delocalize and stabilize this carbocation, and this like migrated here. So like this, the same thing you will get it here. Totally here 3 and here 3. Totally 3 plus 1, 7 resonance structures you will get. Okay. So this structure biphenyl carbocation can form 7 resonance structures. RS means resonance structures, not railway mail service. Yeah. And here this benzyl carbocation. This is these pi electrons. So here conjugation is there. Yeah, pi bond or sigma bond positive 2 charge. So these are delocalized and make double, that is a double bond, and is going to be stable, right? Then it can form how many resonance structures here? There is resonance structures 3 plus 1, totally 4 resonance structures will get. Yeah. Okay. So as then the concept is what the concept behind this one is, now to keep in our mind is the stability of a carbocation. The stability of a carbocation is directly proportional to number of resonance structures. Number of resonance structures. Okay. Yeah. Now this one you have to keep in our mind, this point. Just keep in your mind. Like if this point, like this of questions are appear, you can easily answer it. Yeah. Now number of resonance structures here 10 are there. Is this triphenyl carbocation is more stable. Next biphenyl. Next benzyl is least stable. Yeah, got it. Next one, another example. For example, take it here. It is here in this case, it is a comparison between a benzyl carbocation and allyl carbocation. You know, here pi bond, sigma bond, positive charge is there. So that's why here conjugation is there. Okay. And here also a pi bond, sigma bond, positive charge is there. So here also a conjugation is there. Okay. So the both the compounds conjugation is there means the both the compounds resonance effect is take place. Yeah. But here this pi electron shifted over here, it is going to stable. Fine. Yeah, you get like this. The molecule will get like this. Yeah. double bond and you get positive charge. Yeah. But in this case, okay. So in this case, what you will get is here. Here, this 5 electrons shifted over here, and they make a bond, it is going to stable. Then these electrons are, because if these 2 electrons are migrated over here, then this carbon gets positive charge. Then these 2 pi electrons migrated over here. These 2 pi electrons migrated over here. Then the double bond is formed. This carbon gets positive charge. These 2 migrated over here. These 2 migrated over here. These 2 migrated over here, right? And this carbon gets positive. Then immediately these 5 electrons shifted over here, and they make a bond here. They make a bond here, right? Is it okay? Got it? Yeah. Then because of that, these 2 pi electrons, this you will get, okay, like that. So here the pi electrons are migrated along the length of the carbon chain, right? Here extended resonance is take place, but that is minimum resonance is place in allyl. Okay. So in case of allyl carbocation, the resonance, and also in case of benzyl cation. So which is more stable? There is benzene. Why? Because in case of benzene, extended, that is max. Resonance is maximum, right? You can say maximum resonance. Okay, compared to allyl. So here maximum resonance is take place. So maximum resonance is take place happening. So that's why this you have to keep in our mind. This you have to consider. And here resonance is there, but compared to that one, it is a minimum resonance is happening. So that's why there is benzyl carbocation is more stable. You can get how many resonance structures you get. The number of resonance structures is 3 plus 1. 4 resonance structures you get. 4 resonance structures you get. My dear students, how many resonance structures you will get? 3 plus 1. 4 resonance structures you get. So, but here you get only there is 2 resonance structures you get due to this minimum resonance is there in case of allyl carbocation. So that's why benzyl carbocation is more stable than allyl carbocation. Fine? Yeah. Next one. Is it clear? Fine. So there is a triphenyl carbocation, biphenyl carbocation, and benzyl carbocation. So which factor you have to consider is number of resonance structures formed by the all the structures have resonance, but number of resonance structures will decide the stability, right? Next one is very important. This is, see, for example, the compound is like this one. This is what? It is a benzyl carbocation. Okay, and then it is a tertiary butyl carbocation. It is also all-time favorite question by the students. Which is more stable? Generally, students are confused here, and some books they are not given properly. Okay, so what I have to do is here, which factors I have to consider is to decide is here. So in this case, what is the thing is here? This is a pi bond and sigma bond and positive charge is there. So that's why here conjugation is take place. Wherever conjugation is there, so there what happen? Resonance effect is take place. Whereas wherever resonance effect is happening, then that will stabilize the molecule. Here how many you will get? This migrate over here, then you will get positive charge, and this is migrate over here, you will get positive charge, and this migrate over here. Totally you will get 3 plus 1, you will get 4 resonance structures will get. Fine. But what about here? In this case, it is a tertiary butyl. This is positive charge. Here there is no conjugation, there is no resonance effect, but this is a alpha carbon is there. So carbocation adjacent carbon alpha. That is each alpha carbon having 3 alpha hydrogen atoms. As you know, these alpha hydrogens, there is 8 sigma bonded electrons are in conjugation to the empty pure p orbital of the carbocation. That it forms a bound bond here. It is going to stable like that. How many you get? How many you get means you will get here. So this forms one hyperconjugate structure. This forms, so you will get 3 hyperconjugate structures like that. Here also. So this one also it can form, that is it forms one hyperconjugate structures. It also forms one hyperconjugation. And here also this one also, this alpha hydrogen also having 3 alpha hydrogens. This alpha carbon it can form also 3 hyperconjugate structures. So totally you will get, that is 3 plus 3 plus 3, totally 9 hyperconjugate structures will get. because here 9 alpha hydrogens are available, so that's why they can form 9 hyperconjugative structures. Hyperconjugative structures. What is this? Okay, HCS. That is hyperconjugative structures. HCS, right? Yeah. Now, so that's why here we get 9 hyperconjugative structures. Here we get 4 resolution structures, right? And that too, if you one more factor is also going to happen here in the tertiary butyl carbocation. What is that? Tell me. Yeah. So this is alkyl group, right? So alkyl groups are, that is the plus A group, right? That is electron releasing group, right? Yeah. How many are there, right? Plus A groups, how many are there, right? There is 3 are there. This is also releasing group. They releases electron. So that's why here inductive effect is also operating. Inductive effect also operating, right? So that means totally this hyperconjugation effect structures and inductive effect, the combining effect of these two, you have to consider the combining effect of these two factors you have to consider, right? You have to combining effect. Okay, there is a combining effect of these two is gives more stability to the tertiary butyl carbocation than benzyl carbocation. Take care, very important, my dear student. Okay, ma? Okay, yeah, that is. So here it is giving some more stability. Then sir, just we told the predominant effect is resonance effect than hyperconjugation. Correct. That is common. That is general thing. But here the two combining effect of here 9 hyperconjugate structures, but here only 4 resonance structures. Yeah. So the experimentally they find out that because of 9 hyperconjugate structures maximum are there, and that inductive effect, combining effect will decide more stability to the tertiary butyl carbocation than benzyl carbocation. Okay. Then one more thing, this is also very important. This is so generally in case of there is a benzyl carbocation and then tertiary butyl carbocation, then tertiary butyl carbocation is more stable because in which the two effects whose combining effect is greater, that is somewhat greater stability is there, than this resonance. Okay, the next one, that is so take it here, there is a benzyl carbocation, and then that is here what is there here? This is I'm taking now, there is a CH2 CH3 ethyl group is bonded, and here also CH2 CH3 ethyl group is bonded, and here also CH2 CH3, right? Okay, now if you apply these things, there is ethyl group now. This is what? That is nothing but ethyl group. Okay, ethyl group, C2H5 group. Okay, no, that is fine. Now in this case, okay, so of these two, which is more stable? Okay, generally 90% of students commit a mistake in this one. Okay, so once you know, then you can apply. Tell me now what the answer here. By applying that, you can do. The thing is, you can't mistake. Look here. So in this case, it is a carbon carrying positive carbocation. This is which effect is operated. There is no pi bond or lone pair, so no conjugation. Then maybe inductive hyperconjugation. This is alpha, 2 alpha hydrogens are available. It is alpha, 2 alpha hydrogens are available. It is alpha, 2 alpha hydrogens are available. So that's why totally 6 alpha hydrogens are available. So that we will get 6 hyperconjugative structures. That too. Here, ethyl group is there, na? Ethyl group, okay. Ethyl group. Okay, so ethyl group, that is inductive effect is also operated. And here, which effect is operated here? There is which effect is operated here? This is a pi bond, sigma bond, positive charge. That is conjugation is there. That's why resonance effect is take place. Resonance effect is happening. So that's why it is stabilized by resonance. Okay, but how many resonance structures you get? Come here, this is make a bond here, it is getting positive charge, it is stable now, and it is migrated over here, it is getting positive charge, it is stable now, it is migrated over here, like that. Totally 3 plus 1, totally 4 resonance structures you get. Okay, now here, this is only 6 hyperconjugated structures, as number of alpha are less. Okay, so that's why here 9 hyperconjugated structures, 9 alpha are available. So that's why tertiary butyl carbocation is more stable than benzyl. But in this case, benzyl carbocation is more stable. Keep in your mind. This is benzyl is less stable than tetrahydrite because of methyl groups are there. Alpha hydrogens are more in number, but here ethyl group is there. Alpha hydrogens are less, so that's why that decreases the stability. As number of alpha hydrogens decreases, stability of this one is also decreases. So that's why this is benzyl carbocation is highly stable in this case. Is it clear? Right now. So like this, so 10, 11 examples with different models I explained. Then, okay. So in the next video, because it is more, some more examples are there, okay, that are appearing different need, J mains, J advanced, and KVPY, okay, and PG said this different examples. If you get it that one also, then you will get clear concept. Everything about carbocations you will get it in the next video. I am going to upload it is some specially stable carbocations are there. That is like a tropylium carbocation, right? And cyclopropyl carbocation, then cyclopropyl methyl CPM carbocation. These are all there, okay. And there some more examples are there. So which different factors are available there. Dancing resonance is also there. So that will do the next second part. That is order of stability of carbocations part 2. You can watch it. Then you can get clear idea. Okay. Yeah. Now you got it right, all of you. Yeah. Then like it, subscribe it, and share to your friends, my dear students. Thanks for watching my video. Okay, fine.